proportion z-test. So we really kind of, if you think about a two-sample t-test, we've done a two-sample t-interval, right? So you know how to handle two data sets. Then we've done a t-test, so you know how to handle a test. We're just combining those two things into one method. Like if I really wanted to, I think I could say to you, you have to figure out this template and turn it into me before class is over. I think you guys could probably do it. 9 or 10 snow days kind of makes me want to just move forward, so we're not going to. But I think you could probably do it and be okay. But I'll do it for you. Two-sample t-test. So this would be an example of when you would use it. I just wrote this one third hour. Where you have two data sets and you want to compare them. You want to compare the difference between them. So, like third hour, let's say this last time, I kind of made up numbers, but if there's 30 people in third hour and they average an 82, there's 40 people in this class and they average an 85. Obviously, fifth hour did better, but did you do statistically significantly better? Or is that just like within the margin of error and be like, they're probably about the same, but third hour had a bad day or fifth hour had a good day or whatever. Or are they far enough away they can be like, oh yeah, okay, fifth hour's smart. Third hour's done. So that's what you do. That's an example. That's what we'll do next. So we'll do the template and then we'll do this example. But just kind of keep in mind what we're going for. So mu1 equals true population mean whatever. So I'm going to say like context 1. Remember, we're doing the general template here. We're not doing the problem I just talked about yet. Mu2, true population mean, context 2. So this would be like third hour and fifth hour, or Mild and Saline, or Michigan and Ohio, or whatever, male, female. And then your HO can look a couple different ways. So I usually stick with this mu. I would say mu1 equals mu2. HO always has to be equals. Something equals something. You can also write this as mu1 minus mu2 equals 0. So take a second and just think through. Like those are the same statements, right? Those mean the exact same thing. You can write whichever one you want. You probably need to understand both because when you get questions on the AP test, they can present it either way. HA, so you could get mu1 is greater than, less than, or not equal to mu2. Or if you wrote the second version, this would be like mu1 minus mu2 is greater than, less than, or not equal to 0. And when you're writing it, you can choose whichever version you would like. You can mix it up, you can do whatever. Just understand that they might present it in two different ways. But we see why they're the same statements, right? Like if they are equal, when you subtract them, you will get 0. What's next? On any template. Conditions, yeah, so I need randomness. But I need it for both. I'm going sideways because I know I'm about to run out of room, so I'm trying to conserve space here. I need independence, and I need it for both and from each other. So like third hour students are independent, fifth hour students are independent, and third hour is independent from fifth hour. You remember doing that? We did that with the confidence intervals too. And you can do that in two ways. So you can assume, or you can do that n is less than 10% of the population. Again, I should be familiar, we did that before with the T's. T-tests and the T-intervals. The third thing we need to know is that we can use a T-distribution for both. One of three things needs to accidentally just flipped everybody. One of three things needs to be true. So what are the things? Sorry, that was the next. What could be true? What could I count for t-distribution? So I could have a large sample, so greater than or equal to 30, or what's approximately normal. So it's both actually. So either you can say your population's normal, or your small sample is normal, is approximately normal. So you either have a normal population, or you have a big sample, or you have a small sample, but the small sample looks approximately normal also. Alright, that's the math. So remember on your formula sheets, you're basically either writing this or this every time. We're doing a test, so we want the test statistic. If we were doing a confidence interval, I would want the confidence. This is standardized test statistic. And that's equal to statistic minus parameter over standard deviation of statistic. And then remember that, so there's two data sets, and what we're really trying to do is find the difference between them. So if the difference is between them is 0, what would we say about the two things? They're equal, right? Or if the difference is not 0, then we can maybe say, okay, one's bigger, one's smaller, they're not equal, whatever. But you're always trying to estimate the way I would compare two things is to subtract one from the other and see what I get. So I don't even know if you guys think about this ever, but what's bigger, 8 or 6? What's the difference between 8 and 6? 2. How'd you get that? You're subtracting, really. I think most of you are just like, oh, they're 2 apart. Like, it just makes sense. But it's really subtraction. You're talking about the difference. You subtract. So here I need to subtract the sample mean. How do I represent sample mean? X bar. So the statistic is the subtraction of the sample means. X bar 1 minus X bar 2. So how far apart are our sample means? So in this case, like when I get to this next problem, it'd be like 82 minus 85. Then I want to subtract the parameter. Well, the parameter is the difference between the population means. How do I notate that? mu1 minus mu2. And that's a nice, it kind of simplifies for us. Let's start on that. What is mu1 minus mu2 in every single one of these? It's 0. So when you go to do you have to write it here for the formula, but when you go to do the math part, this is 0 every time, because didn't we up here say, hey, mu1 and mu2 are the same? Or if I subtract them, I get 0. So that's the population that we assume is true, so you're always going to subtract 0. And then the standard deviation, again, you got a formula sheet for a reason. 2 samples, difference of sample means, and then you got these 2 formulas. I'm never ever going to worry about the special case, because if I have a formula that works every single time, I'm just going to use the formula that works every single time. So that's the standard deviation of the statistic. You don't have to memorize it, just write it down from the formula sheet. And then I'm going to plug in all my numbers and get an answer and keep going. So is this a standardized test statistic? Is it T or Z in this case? T, because we're in means. And then you would plug in like a number for x bar 1, a number for x bar 2. And then here you just put minus 0. Because again, and you don't even need to put the minus 0, because subtracting 0 really doesn't do it. I like to put it because it kind of reminds me that I'm always comparing the difference that I get to 0 to see like how far apart they are. But you don't have to. And then down here you're putting your numbers. And then you're going to get a T-value. What does the T-value tell you? I guess I should ask that question. What does the Z-score tell you? How many standard deviations you want away from the mean? T is the same thing. Like, if I got T equals 2, that means I'm 2 standard deviations above the mean. It's just the mean's version of it instead of Z's. Alright, at this point, you take your t-value and you use TCDF, right? And when you do the TCDF, you're going to get a p-value. But if you remember on the previous one, there's like 3 situations. You know, if it's less than, then I'm going to do TCDF in this way. If it's greater than, I'm going to do TCDF in this way. If it's not equal to, I'm going to do TCDF in this way. Is it okay if I just write use TCDF to find p-value, or do you want me to do all 3 of those scenarios? Do you understand the question I'm asking? So what do you think? So third hour said that was fine. If you get to a point where you're like, hey, this wasn't enough for me, I can do more. But what I just want to write use t-value and TCDF to find p-value. And that's where, like, if you're in the lower tail, you're going to do like negative 999 up to negative whatever. If you're in the upper tail, you're going to do whatever coming 999. But remember, if it's not equal to, what do you have to do? When you find the p-value, you have to double it. Although if you do it in the calculator doubles it for you. Okay, then you're going to have an alpha. So alpha equals whatever. You're going to have a degrees of freedom. We won't know until the calculator tells us. Then we're going to have a drawing and a conclusion. So for the drawing, what goes in the middle? So mu1 minus mu2 is acceptable, but I can make, I'm a little lazy. I don't want to write mu1 minus mu2. I can put 0. You can put mu1 minus mu2. That's a good answer. I don't put 0. And then, again, I could do, there's like 3 possible scenarios here. You might be over there, you might be over there. I'm just going to draw one of them and like hope you can figure out, okay, I know how to do the other ones. Is that reasonable at this point? Okay. So let's just say I was over here. Then I would put like x bar 1 minus x bar 2. I would put t equals whatever. And I would shade this little part there. So what would HA be if I were doing this? Greater than, less than, or not equal to? This would be greater than. If I was doing less than, I'd be over here, right? If I was doing not equal to, it'd be both. Question? Yeah?
Do we have to write the x bars, or is that another one where you write whatever your number is?
You could do the number there too, actually, yeah. So you could put, like, if I were doing that one, I would put negative 3, and that's fine. That's fine, yeah. That works. So I could put a number here too. Any other questions? I think I just didn't think to write it because it's like not always the same number like the 0 is. All right, then you got your 2 conclusions. So I'm going to write both these out just because I think some of you still need some practice with them. 2 options. So since p-value, let's start with this less than 0. What would we do in that case? Or less than alpha. What would we do in that case? We reject HO. And if I'm rejecting HO, it's because I think HA is better. So there is enough evidence to support HA. And then we do think or do not think HA is true. We do think, so you're either going to say I do think HA is true or I do not. But you don't write HA, you write like the actual like greater than or less than thing. So in this one I would put we do think mu1 minus mu2 greater than or not equal to or less than 0, or whatever HA says. Or you could write it, the choices almost make it seem more confusing, but you could write it this way too, depending on how you wrote your HO and HA. And then the opposite, so since p-value is greater than alpha, now we would fail to reject HO. There's not enough evidence to support HA. We do not think mu1 is greater than, less than mu2, whatever the case was. Questions on just the template? Just general overview. Okay, let's do one. Am I good to remove this? I need it. So I'm gonna do the one on the board, the 3rd hour versus 5th hour. Let's see if you guys are smarter. 2-sample t-tests. How do I know it's T and not Z? Means, how do I know it's tests and not intervals? So I asked it what? I kind of asked a question. I was trying to ask. Fifth claims they did significantly better. I guess I would say like fifth claims they did better. Did they? Like that's your yes/no question. And then why is it 2 samples instead of 1? 2 data sets, right? So just thinking through all 3 of those. So the mu1, you'd say true population mean 3rd hour test score. This is kind of a weird example because it implies that I'm taking a sample. I'm really not. So we have to pretend there's like 300 people in 3rd hour and like 400 people in this one. We're at a big college or something. That's okay. Then mu2 would be true population mean 5th hour. And then HO. So I prefer to write it this way. You can do the mu1 minus mu2 equals 0. There's nothing wrong with that. This just works better in my brain, but my brain's kind of goofy, so whatever works for you. And I'm going to say HA. Is mu1 less than mu2, greater than mu2, or different? The way this is phrased, we're testing to see if mu1 is less. Because mu2 is 5th hour, and someone in here claimed they were smarter or something. So we're testing to see if it's actually higher than 3. So conditions. SRS stated for both. And then I got to do independence and I got to do t-distribution. Doesn't really matter which is next, but let's do independence next. I can't really do are there really 300 people in my 3rd hour? No, so technically I shouldn't be doing the 10% thing, and I would say assume each student independent, and what else? Each class independent, yeah. And then a t-distribution how do I know I can use a t-distribution in this case? What makes it qualify? Both samples are large. And then I would go, okay, 40 is greater than or equal to 30, and 30 is greater than or equal to 30. Just kind of showing the person grading it that 30 is the cutoff. We alright? I feel like I'm going fast. We're fine. We're good. Move on. So standardized test statistic equals statistic minus parameter. Part of it I'm trying to go fast. I know this is boring. You guys have been doing these for a while now. So you just write down the formula. And then, what is the statistic in this case? Remember, we're doing two samples. We want the difference between them. So x bar 1 minus x bar 2. And the parameter is mu1 minus mu2. And that's all over this standard deviation formula that you just copied from your formula sheet. So then we're going to plug in our numbers. So the standardized test statistic is t. What's x bar 1? 82. The way I define things, third hour is like the first sample. Minus 85. So this is x bar 1 minus x bar 2. And again, what's mu1 minus mu2 in all of these? 0. And then I'm going to plug in all that stuff on the bottom. So this is 5 squared over 30. 6 squared over 40. And I know some of you have been like typing this into your calculator to get t instead of having the program do it. I think on this it just it's just more annoying at this point because there's more crap in there. So I would do this on the calculator every time. You're also going to need the calculator to tell you the degrees of freedom, so you're going to have to use the calculator test on this one. So get your calculator out, do it with me. So stat test, 2 sample t-test. And then go ahead, I'm just leaving it up so people can see, but go ahead and enter, and it tells you what to type in. You just type in what it asks. When it asks for pool, you put no. It's always you know. So I'll put 82, 5, 30, 85, 6, 40. I always want this sign to point the same direction that my HA sign points. I always want pool to be no. And then I can do calculate or see what draw looks like. This is why I don't use draw ever. I always forget because it takes forever. Yeah. It's kind of cool, but it's like I get impatient. Alright, so are you guys getting that T and that P value? Like you might have done the calculate instead of draw, but are you getting the same numbers? Questions? Everybody's not working? Any issues? Then just calculate it.
Yeah.
Like,
I
don't know how to fix that.
It's fine, just auto to the size.
That's what's supposed to happen. But, I mean, so if we reset your memory, we can probably fix it, but I don't think it's not that big. So if you do the calculate, I mean, you can save stuff, right?
Yeah.
It's just not as cool of it. So the thing is, you do have to do something a little bit here that you're kind of jumping through a hoop. So this is my t, something like that. I get 2.2787. You have to pretend that you found the p-value on your own. So if I thought about a sketch, my t-value is way down here. And I want to find this p-value. You have to write it out as though you are the one finding it and pretend the calculator didn't just straight up tell you. So I'm going to use TCDF, and am I going to do this number, comma 999, or am I going to do negative 999, comma this number? Negative 999, comma that number, and you actually need another number, which is actually another reason not to use draw, because draw doesn't give you this number. What else do I need at the end of that? I need degrees of freedom, which is what? 67.19. So if you did draw, it actually doesn't tell you that. So that's another con for draw. And what does this tell me? When I calculate this, what am I finding? Find the p-value. And this problem, we get 0.0129. So label that degrees of freedom. So this makes them feel like you know how to find it on your own if the calculator can just spit it out at you. I didn't tell you alpha, so let's write 0.05 before I forget to put something there. Am I missing anything? I think I'm good. I'm not done, but so far I think I'm good. What do I need here in my graph? I'm going to put 0. Over here I can put one of two things. I could put x bar 1 minus x bar 2, or I could put what x bar 1 minus x bar 2 is. What is x bar 1 minus x bar 2? Negative 3. So you can put negative 3 there. You don't need both of those, you just need one of them. So all that's my math box, and all I have left to write is a conclusion. Yeah?
So df off to the side.
So like somewhere else, you put df equals 67.19. Then that's, yeah, you just did it once. Could be anywhere. Remember, they have to grade the whole paper, so like technically you could, like, in the middle of the word population, or the POP, df equals 67, UL8, and they would like technically have to grade. Any other questions? Yeah?
So both sides of the 0 are x bar 1 minus x bar 2, so you have the same number. Is that logical?
Maybe. But I didn't really quite get what you were saying.
Okay, so like on the graph,
Yeah.
you know, like if it's two-tailed test.
It could come out positive or negative. So if you were doing a two-tailed test, over here you would put 3. And you would put t equals positive 2.2787.
Well, x bar 1 minus x bar 2. For both of them.
You're saying let's not do the number, we're going to do the letters. Then you can put that in both spots, yes.
Square. Actually, why is it the same thing? Because x bar 1 minus x bar 2 will give you the same answer.
It will. So you can put x bar 1 minus x bar 2 there, and like the implication is that it could be negative or positive depending on which side we're.
Okay.
Or you could put x bar 2 minus x bar 1, which would make it positive.
Okay.
Or you could take this negative number over here and just put the positive version of it over here.
Okay.
They just want some sort of indication that you understand it's symmetrical.
I understand that. No idea.
Oh.
Yeah,
Okay. Well, I'm glad I said it. Yeah.
I was just really listening to what you said.
We're good. Okay. Any other questions? Okay. So, am I rejecting or failing to reject? Rejecting, right? Why? P-value is less than alpha. Makes sense. P-value is less than alpha. We reject H naught. So I'm rejecting H naught. That means I think AJ is better, or I wouldn't have rejected H naught in the first place. So there is enough evidence that make sense what we're doing? Questions on any of that process, the template, the example? Okay, so we'll do the 2 prop Z test on Monday. Tuesday, I will give you the class period to work on con, but I'm also assigning the con now, so if you want to start, your con's going to be due on Wednesday. We're done for now, so you could use this time to start your con. If you want to start this weekend, go for it. You will have Tuesday in class. I don't think that's enough to finish, though, so make sure you build some other time somewhere. It's going to be due Wednesday, yeah. Oh, I didn't really leave any time for that, what I just said, did I?
You can read it after they're already taking it. That's not that good.
We'll just shove everything back a day. So it'll be Monday, check tests, Tuesday, 2 prop Z, Wednesday, time for con, and I'll change your con so it's due Thursday. You want lit con also? So con due Thursday. Good point, sir. Thank you.